Another meaning for slope is rate of change. That's what we're going to be talking about in this video, the two kinds of rates of change that we have learned about at this point in our lives, the final part of lesson 2-5. So, now that we have a way of finding the derivative, we have a way of finding another kind of slope. So we have now two ways of finding slope or rate of change. We have rate of change classic, average rate of change, the slope between 2 points, the one you've been doing your whole life, is found without using a derivative, algebraically. To these formulas, I'll add the fact that y2 is just f of x2 minus f of x1 all over x2 minus x1, and that in this class, a lot of the time instead of using x2 and x1, we'll be using a and b. So we're talking about f of b minus f of a all over b minus a. F of a, believe it or not. Average rate of change. That's it. The slope between 2 points, we would also maybe call that the secant slope. The slope of a secant line. Okay. Instantaneous rate of change will be the slope at a single point. It's usually found by using a derivative or a calculus type technique. This is also known as the slope of a tangent line. Okay? So if you see someone asking you for a secant slope, it's an average rate of change. AROC, if you see someone looking for a slope of a tangent line or a slope at a single point, talking about an IROC, instantaneous rate of change, derivative. Okay, so let's apply those techniques. Find the average rate of change, the AROC, from 10 till 30. Another way this question could be asked is on this interval, 10, 30. Be careful. So we're going to find the average rate of change by doing f of 30 minus f of 10 all over 30 minus 10. F of 30, 30 cubed plus 2 times 30 minus parenthesis, make sure you use those parentheses, 10 cubed plus 2 times 10 all over 20. On the AP test, on my test, if you have the option, that is okay to do. It's okay to stop there. This is a numerical answer. It also is right. You'll get full credit for this answer if the problem doesn't say simplify, if it's not a multiple choice problem. Otherwise, we have to say that's 2,700, no, 27,060 minus 1,020 all over 20. And that happens to be 26,040, 20, which is 1302. Okay? Again, none of these other answers make any more sense to me than that answer. If the problem asks you, if it gave you a simplified all the way down to here, it's probably this. Sorry, on the multiple choice. It's probably that's what you're looking for multiple choice. It's usually not of this form or this form or this form. Please be careful. Usually you won't be asked to simplify all the way down to here without a calculator. But if you are, just work carefully. Whereas the instantaneous rate of change for the same function, now just at a single point. Notice that that's a single point. It's not a range of points. The IROC will involve us taking the derivative. 3 comes down. 3 minus 1 square. The derivative of 2x. This is a line with a slope of 2. So what's the derivative? It's just 2. You could also say it's 2x to the 1. 1 times 2 is 2. But I don't think that's good. We're going to have to get to the point where we know the derivative of 2x is 2. The x sort of just pops off. So IROC f prime of 10, 3 times 10 squared plus 2. Look how this is labeled. Look how I don't say this equals 302 or 3 times 10 squared times plus 2. Equals 3 times 100 plus 2. So the IROC. So notice that an IROC and an AROC can be wildly different numbers. Hugely different numbers. They're not related necessarily. We'll talk in later lessons about how they could be related. So now you've seen some of the basic uses of derivatives, as well as some problems, the non-differentiability, and just how to take them without doing a messy limit. Go do some derivatives. All of 2-5 should be doable now. All of 2-6 should be doable by now. Good luck. Have fun. Don't hurt nobody. Bye-bye.